Okay, so alright, so good day class. So today we're going to have a short lecture on foundation systems, heavy reinforced concrete, pre-stressed concrete and steel construction. So let me read this. So the foundation system transfers the lateral loads on the superstructure to the grounds. The horizontal component of these lateral forces is transferred largely through a combination of soil friction on the bottom of footings and the development of passive soil pressure on the sides of footings and foundation walls. Foundation systems are classified in two broad categories. First are shallow foundations and the second are deep foundations. So when you say shallow foundations class, so as illustrated here, it means that it's not that deep. Okay, it's for to understand it simply. So when you say deep foundations, those are the times when you're going to dig in some piles. If you're going to look at, if you have seen the construction of large buildings, what they do first, especially if the ground is soft, is that they dig. Okay, they dig piles until it reaches a stable stratum of soil before you're going to place the foundation. Okay. In shallow foundation, you don't need to put piles anymore. So it's just resting above the ground. So it would really depend, class, on the recommendations of your structural engineer after a geotechnical analysis has been conducted. Okay, so it's really important that you understand these concepts. Okay, then later on, when you reach your higher years, I think particularly in your fourth year, fifth year of study in architecture, I think you'll be taught on how to compute the loading, different loadings. Concern now in building tech 2 is just that you understand this a bit. So shallow foundations. So shallow foundations are employed when stable soil of adequate bearing capacity occurs relatively near the ground surface. So and this is the common type of foundation that you're going to see and encounter class throughout your practice if you're just going to do residential designs. But if you're going to build near what you call this, near the ocean, the soil conditions also change. So there are times that, especially if you are building near the sea, that the soil underground could be subject to liquefaction. So that is why you should try to do structural analysis first, or try to get a history of the area. So it's structural analysis is really important, and geotechnical analysis also. So you get a sample of the soil and determine if there is a stable or soil stratum underneath. And then usually once the results come out, then you can uh, what you call this, meet with your client and tell him about the soil conditions in this area. So probably in my experience is that we reduce the size of the house uh, because the soil conditions would not permit a larger structure. So that's when you in cases like that class, you'll have to look into materials that are light. Then see, so individual or isolated footings are spread footings, supporting standing columns and piers. So when you say piers, it's also columns or made of wood. So this is example of a block or square footing. If you notice that our activity just uses block or simple square footings. These are stepped footings. This is something that I haven't encountered yet in my practice. And we also have what you call the slope or pyramidal footings. So I rarely encounter engineers class who design their footings in this manner. That's B and C. But probably they exist based on the conditions, and it could probably depend on the designer also. You also have what you call strip footings. So these are continuous uh, spread footings of foundation walls. So strip footings are footings that change levels to accommodate the sloping grade and maintain the detail required depth at all points around the building. So this is an example of a strip footing here. This is an example of a stepped footing. So I think it's easy to understand the concept if you look at the diagram in the drawing. Then you have combined footings. So I think in my experience class, combined footings, these usually happen. So combined footings class, these usually happen if the columns are too close to each other. So instead of uh, doing it doing the foundations separately, so you just combine them because they are too close. Okay, so those are combined footings. Let's move on to the next here. So this is for example here, the example of a combined footing. So the footing is so designed so that the center of gravity of the combined load passes to the center of gravity of the footing area. Combined footings are usually rectangular or trapezoidal in shape, depending on the case. But usually, if the 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 shape of the lot permits it, it's usually rectangular in shape. Okay, then you have also what you call cantilevered footing. So this type of footing may be used in place of a combined footing under the same conditions. So in this type of construction, the footings of the exterior and interior columns are connected by a tie beam or a strap which is so extended to support the exterior column. So the top of the beam or strap is usually placed level with the top of the footing. So this usually happens class here if you're going to be near the property line because you cannot encroach uh, the foundation to the other side where which does not belong to the client that you're engaging with. So if this is the property line of the property that you're building, okay, here you cannot cross the other side. Hence, you're going to use a cantilevered type of footing. Then there is also continuous footing. So this may be supporting a line of columns, then supporting all of the columns by strips at right angles to each other. So this usually happens class if I think the distance of between the columns are too close. Okay, so if it's just around let's say around zero point 0.5 or zero point 0.2, then it's too close to each other. If the design of the foundation is designed that way, then why not just combine everything? Okay, instead of working meticulously on the individual isolated footings. It will just save time and effort to just combine them. So then you have what you call the mat or rift foundation. So mat foundations like continuous footings are used on soil of low bearing power where there's a tendency towards unequal settlement due to unequal loading of soil. So in this type of foundation, all parts of the foundation are so tied together that they will act as one and assist each other in keeping a level and plumb. Okay, so mat foundation we divide into the following general classes. One is flat slabs of plain or reinforced concrete, beams or girder with a slab underneath, and then beams or girder with a slab on the top. Okay, so the usually class, I think the advantage of mat foundation is that it will act it it's like your building or structure is resting on top of a boat. So it's just like it's floating. Okay. So I think it's relatively safe, but the downside is that it would be quite expensive. The construction cost might go up by a lot. So depending on the case, you will do mat foundation if it is recommended by the structural engineer, depending also on the soil conditions. Then you have what you call the steel village foundation. So when it is desired to avoid deep excavation required for concrete and masonry footings, and the load has to be distributed over a wide area of support, steel rails or beams are used to give the required moment of resistance with a minimum of depth. So for steel village foundations, the foundation bed should first be covered with a layer of concrete not less than 6 inches in thickness and so mixed and compacted as to be nearly impervious to moisture as possible. The beams are placed on this layer, the upper surface brought to a line and the lower flanges carefully grouted so as to secure an even bearing. So subsequently, concrete should be placed between the and around the beams so as to permanently protect them. So the beam must not be spaced so near as to prevent the placing of concrete between them. So the clear space between the flanges of the top layer of the beam should not be less than 2 inches and should be somewhat more for the lower layers. So these are the I-beams glass. This is steel base plate. Okay, so I think this is concrete here. That's around zero point 0.1. The real challenge here is uh, placing concrete in between the I-beams. For me that's the real challenge, especially in the actual construction. So that's why it requires a lot of skill class if you're managing a construction site. Okay? Because you have to make sure that the drawings are followed, and then should be no gaps in between. So I think when you will be working already, when you first get your license, especially if not you're not practicing yet, it would be beneficial class if you're going to experience gain experience first working in large projects, so that when you practice a few years later, you already know how to do it. Okay, because if there are some things that cannot be taught inside the classroom, so you must learn them by experience. Then for deep foundation, so deep foundations are employed when the soil underlying a shallow foundation is unstable or inadequate soil bearing capacity. So the usual step class is to have the soil tested. So if its soil bearing capacity is not that good, or if it's too low, then you'll go into deep foundation. So they extend down through unsuitable soil to transfer building loads to a more appropriate bearing stratum of rock or dense and gravel well below the superstructure. So the types of deep foundations are pile and caisson foundations. So these are an example of a pile foundation here. So this is the column load. So a pile foundation is a system of end bearing or friction piles, okay, pile caps, and tie beams for transferring building loads down to a suitable bearing stratum. Okay, so this one here. Then you have end bearing piles. So it depends principally on the bearing capacity of soil or rock beneath their feet or support. So the surrounding soil mass provides a degree of lateral stability for the long compression membrane. And you have friction piles. So depend principally on the frictional resistance of the surrounding earth mass for support. Okay, I think these are the friction piles class. Okay. So here, in the friction piles, okay, it relies on the friction of the soil. So you can notice that it has not yet reached this soil stratum that is hard. Okay, these are the pile caps. So that's the advantage of the friction taps. Well, the other type kind of piles, you must reach the hard portion here. Okay. Then you could also do something like, if it's just a small residential project, you could also class bury piles. Okay, if you bury piles at intervals here, you could strengthen the soil also. It's like you're compacting the soil already, making it strong before you're going to build a shallow foundation of a house. Okay, so let's end our lecture here at friction piles. So we will continue next meeting and we'll continue working on your activities. Okay, so if you have any further questions or clarifications, class, feel free to ask anytime. Then, yep, probably next meeting we'll try to look into the different wood connection details that you could use when you are already designing your own um, structures, especially after the midterm. So you'll not copy anymore the drawings that I'm giving you. You're going to have to start your own, but it's going to be just a simple exercise. Okay, so the purpose would just be to orient your class. Okay? At least you know what are the different construction documents. Okay, so I hope that you learned something. And if you have any further questions or clarifications, you can reach me anytime. Okay, so stay safe, class, and see you next meeting.